Right, so this is the first video for Unit 6. Unit 6 is all about mechanical energy. The first idea we need to talk about is something called kinetic energy. Kinetic energy is the energy of an object when it's moving. So when you move, you have kinetic energy. And kinetic energy depends on the speed of an object and the mass of that particular object. And the formula is kinetic energy is 1/2 times the mass of the object times its speed squared. And just use the variables. Ke, which is kinetic energy, is 1/2 mv squared. The unit for Ke, that's kinetic energy, is joules. The unit for mass, which is m, is kilograms. And the unit for speed or velocity, which is v, is meters per second. Okay, so just some relationships here. Kinetic energy is directly proportional to the mass of the object. So the more mass you have when it's moving, the more kinetic energy it has. Kinetic energy is proportional to the square of the object's velocity. So again, like it shows on here, if the mass doubles, the kinetic energy doubles as well. But if the velocity doubles, the kinetic energy increases by 4 times because of that squared relationship. So if you triple your velocity, your kinetic energy increases by 9 times as much. Okay, so we're going to do a little sample problem here. What's the mass of an object traveling at 5 meters per second with 200 joules of kinetic energy? So we know our kinetic energy is 200 joules. Our velocity is 5 meters. We don't know our mass. The formula is kinetic energy is 1/2 mass times velocity squared. So our kinetic energy is 200 joules times 1/2 times the mass we don't know times our 5 meters per second, which is our velocity, squared. So 200 is equal to 1/2 times the mass times 5 squared is 25. Meters squared per second squared are the units. So on the right side, 1/2 of 25 is 12.5. So to get m by itself, we have to divide both sides by 12.5. So 200 joules divided by 12.5 meters squared per second squared gets us a mass of 16 kilograms. The other type of mechanical energy is called potential energy. Now, potential energy is the energy associated with an object because of where it's at. Mainly when you're looking at like gravitational potential energy, how high it is above the ground. Okay, so gravitational potential energy is the potential energy stored in gravitational fields of interacting objects. So two objects that are separated, the gravitational potential is the interaction between their fields of interaction. And the formula for this is Pe, gravitational, is mass times g, which is free fall acceleration, which we're going to just use 10, times the height you are above whatever you deem as 0. So PeG, potential gravitational potential energy, the unit again is joules because it's energy. All energy's unit is joules. M, mass, the unit is kilograms. G, free fall acceleration, it's 10 meters per second squared. And then the height, h, the unit is meters. The only way that gravitational acceleration, free fall acceleration changes is if you go to a different planet. All right, so a little more relationships here. Potential energy is directly proportional to the mass of your object. So the more mass, the more gravitational potential energy you have if they're at the same height. Potential energy is directly proportional to the height. So the higher you are above the ground, the more potential you have to come back to the ground. And potential energy is directly proportional to the acceleration due to gravity. So if you have greater acceleration due to gravity, you're going to have a greater gravitational potential energy. But since all things that are in the same gravitational field have the same free fall acceleration, that part remains constant. All right, so sample problem. How high above the ground is a 10 kilogram object if it has 500 joules of gravitational potential energy? So we have our potential energy is 500 joules, our mass is 10 kilograms, our g is 10 meters per second squared, and we're solving for h. All right, so we start off with the formula, P equals mgh. Pe is 500 joules, is equal to 10 kilograms. G is 10 meters per second squared, and we don't know our h. So we have 500 on the left side is equal to 10 times 10 is 100. kilograms times meters per second squared times your height that you don't know. So to solve for height, you're going to take 500 joules divided by 100 kilograms times meters per second squared. And the height of this thing, in order to meet all of these variables, the height is 5 meters. So again, this is kind of a blurry picture, but potential energy is at the top. As it goes up, it gains potential energy. When it falls, it's moving, it's speeding up, it's moving, so it has kinetic energy. So potential energy is when it's sitting still, kinetic energy is when it's moving. And that is the end of the first video. So take some time now to do the formative assessment, and remember you need to get 80% correct on the formative assessment. If not, do it again. If you have any questions, please ask them in class. We'll see you in class.